So, thank you for attending. I'm talking about a pretty specific topic right now compared to some of the other things that you've been hearing. And this is about distillation. And Pope Scientific has been involved in distillation for several decades. We've been involved in distillation since the 70s for a lot of different industries. And in the last 5-6 years, it found its way, or the industry found its way to us. And it's become a very important development. So what we're doing is everyone at some point, if they're making extracts, you've got different ways of making the extract. Could be CO2, butane, ethanol, and there's others. And what's been happening a lot in the United States anyway is a lot of trim is used from flour. Now people are starting to use the flour as well. It's typical you wind up going to about 65%, 60, 65, 70%. And if you just simply distill that, which doesn't require any solvents or anything, you can take it up to 85, 90%, and you can distill it again and go up to 95. It's a nice clear yellow material. We're leaving behind heavy stuff, the larger waxes that might have gotten through winterization, salts, sugars, sometimes the high molecular weight pesticides, and you get a nice clear yellow. We'll see that in just a minute from darker material. If it's going to be used as a vape material, it's better to leave out these heavies and chlorophyll and so on. It's not really all that great for you. It's not part of the entourage really so much. It's an arguable thing, but and then if you're going to be isolating afterwards, it's a great thing to go from 65 up to 90% or so before you isolate, because you'll wind up not just with better purity, but a lot better yield. Here in Israel, I've picked up on, for some reason, I don't know, that a lot of people think, well, they'll just skip around distillation and not do it. You can do it, but you're going to sacrifice a lot of yield. So, and again, there's no solvents that we've introduced and have to take out again either. So, what's the just to sort of lay out the perspective of how this fits in? Typically, after you remove, after you do your extraction, most people are familiar with the taking away of wax with winterization in cold ethanol and filtration. After that, you've got to evaporate all that ethanol away. It's not always that easy to take it down to very, very low levels. I'll talk about that. Decarboxylation is often used, not always, but that's often done after you evaporate the ethanol away. And there's other things like that certain people are doing, like activated carbon, bleaching with diatomaceous earth, that sort of thing. So this is, some people wonder why even bother with distillation. It's going to take out some of the entourage, the full spectrum thing. Well, here's the thing. If you're going to be doing distillation, really good distillation, you're going to minimize your terpenes. But those terpenes can always be added back in. And it doesn't have to be from that exact same strain. Even within certain strains, you're going to get drift with harvest and so on. So the other thing is you can recover, Want to go backwards? Yeah. You can recover terpenes with the molecular still. We have an external condenser on there. And so I bring this up. As the analyses get stronger and stronger every year, there's still development. A lot of people know there's still long ways to go to get perfect analysis of cannabinoid. But pretty soon, they'll have it developed to a point where you'll have exactly this much cannabinoid of this type, this much of that type, exactly this much terpene, and so on. I mean, that's where it's going to be headed. And so eventually, you'll be able to identify which exactly are the best ones to have and not have in a so-called full spectrum. So distillation is still worth, in our thoughts, still doing, even if you're after the full spectrum effect. The first thing that people think about, that some people think about in distillation is what we call a pot still. It's just basically, it's like a moonshine still, just a simple retort. You're boiling in a flask, you have it under vacuum, and here's your condenser. Diagrammatically, here it is. And this somehow has been called a short path still in this industry, but there's nothing short path about it. It also sits in here for a long time, like hours, and it can degrade while it's just sitting there in a batch mode. And it's limited for scale up. To have really large versions of this doesn't really work very well. So what a white film molecular still, also called a short path still, and it's really a short path. We'll see that in a second. This is what you have. It's a continuous mode process. You have a feed flask. If it's an industrial setup, it's got a tank and a pump. But the material's coming down, and during the process of only a few seconds, the cannabinoid is going to distill away and leave behind the heavier stuff, for example, the chlorophyll, the heavier lipids, salts and sugars. They're there. There's a lot of stuff there that you really don't want. And here I'm showing terpenes can be collected, and then you have a cold trap to help remove whatever small amount of solvent there should be in your vacuum pump. This is what the 2-inch unit, we had one on display here. This is a 2-inch unit. This is something that would be good for, say, about 1 liter per day. And you're doing 2 passes. One to remove volatiles like leftover ethanol, it's there, and water. And then the next time you go through, it can go to really high vacuum, which keeps your temperature down. It keeps it very well behaved. So it's just something that you want to do when you go to high vacuum. All right, so here's a little bit of a better diagram. You're bringing in material. In this case, here's a pump. It's the same thing. As it's coming down, you're heating it on the outside. There's wipers that are turning around. It's slotted. You have a very thin film of liquid here, and this is being highly mixed. And you've got the vapors condensing off, going to this internal condenser, which is kept at about 70 degrees because cannabinoid needs to be at that temperature to flow nicely. And here's a cold trap. And so here we see it kind of more enlarged. The red would be your chlorophyll and other things. The yellow is your product. And you're driving heat through the wall while it's being wiped around. This is sort of a kind of a busy way to show the same thing. This is like a little bit of a detail. There's a micro layer of liquid. It's only maybe a millimeter, it's less than a millimeter thick. There's a high degree of turbulence going on, so it's very, very efficient. So what does it look like? This is your material coming down. This is your residue. And you can see it's quite dark, depending on the quality of your original material. It can be like almost black or just a dark red, greenish material. And here's your clear cannabinoid. This is showing the same thing. It's just this is a bigger industrial process unit. So you can see the residue, and here's your distillate coming out. Okay, here you can see it in motion a little bit. I just showed the feed flask, and there's your dark residue, and there's your distillate. Okay, so this is not going to win an Academy Award, but it sort of gives you an idea of what this looks like. Next time I'll have better videos. But online you can actually see this. There's a number of places to see this live. I'll just sort of glaze over this because this is not to memorize all these parameters and so on, but I just want to bring up, you want to get rid of your ethanol very, very well from your winterization. It doesn't disappear as easily as some would think, just based on the boiling point. There's some hydrogen bonding. It's hard to drive it out of the oil. It just wants to stay there. So you really have to blast it out. We do a first pass through the still to remove the gases and lights and leftover ethanol and so on. Doing that will prevent flashing and darkening and contaminating your product in the next pass. And it's not high value. It's like 1 to 3 millibar. Temperature's not too high. Second pass is where we're actually distilling that, like we showed in the graphic. Maybe anywhere between 140 to 100 degrees C at about 0.05 to 0.4 millibar. You can make a third pass to redistill the distillate. That's where if you want to go from 89 or whatever to 95%, you can do that. You can also recycle the residue that's left over, if there is any. And I mentioned already during passes 1 and 2, you can collect some of the terpenes in that external condenser. So these are showing a couple of different sizes of stills. This guy here, this little one is good for about 1 liter per day of processing. The 6-inch one, it's a bigger unit. It's good for maybe about 10 liters per day, depending on your starting material and what your goals are. So I mentioned 2 passes. When you start to scale up, why not just put one stage after another one and keep going right through the system? And that's what this is showing. Your residue is being pumped away and then going into the next stage. Okay, and then so out of here, your distillate is the product, your residue is the waste material. You can do some other things with it. And here's a typical machine that shows the 2 stages. This is what it would look like, and this is a 10 kilograms per hour machine. Computer controlled, it's got flow meters. It's a very good, precise machine. This is a larger system. It's a 3-stage unit. It's got a lot more. This is for actually pharmaceutical cannabinoids. And then this gets larger and larger. What's nice about this technique is it scales up. Not everything can scale up so nicely, like batch processes, bigger things really don't work out, but this can get up quite high. This is a toll distillation plant that we have where we take materials in from people and we process them. And it can be lots of different industries, food, vitamins, polymers, everything. Here's another larger unit. So kind of closing with this concept, a couple of things. The white film molecular stills and those so-called short pass, which are not short pass, they have one basically theoretical plate. So you can't separate, let's say, for example, THC and CBD. That's not the goal of what we've seen so far. It's to clean it up into very nice purity material, and so that if you can isolate, that goes much better if you're going to isolate. There's other techniques for downstream isolating, and that includes chromatography. A lot of people are familiar with that. And crystallizing, again, a lot of people are familiar with that. Those are two different routes. There's other ones. But there's another approach that is possible, and that's hybrid distillation is what we call it. And what we're doing is taking a white film evaporator body and putting an actual packed column on it with multiple theoretical plates. And this has been a really important technique for example, for omega-3 esters from fish oil and from algae sources, getting into the EPA and DHA, which are C20 and C22. And this is kind of what this looks like. Here you've got, instead of going just to an internal condenser, you're taking the vapor up a packed column. You can force the reflux on it. Here's a small lab scale. This is one production unit that is for omega-3. This is actually a 4-stage unit that has a molecular still, a white film evaporator, and 2 hybrid stills. And the idea there is you're removing contaminants on the left of the peak here, and then when you pass that up to the next or the 4th stage, you're distilling your product overhead and leaving behind the peaks to the right of the peak. And there have been people that have been using this technique for cannabinoids, and they have told us, we have clients that have been actually saying they're separating the THC from CBD, for example. So there's some work that has to be done there. There's a lot of interesting pathways, and that's it. That's what I got. Any questions?
All right. A lot of pictures being taken. A lot of pictures on that one. So they're just going to file them in the phones, and that'll be that. Thank you, sir.
Okay.
Yeah, sure. Over here. Hold
Yes.
on, I'll get you the microphone. How long is the cycle between
one process and the other?
one process and the other?
You have to clean the machine, you have to reset it.
Well, there is some cleaning that is normally done. You'd be taking some solvent through it. You don't have to take the machine apart every time. People put through solvents and some water, and you can clean it out that way. It's not that difficult to maintain.
How long does it take?
How long does what take?
The cleaning process, the solvent process?
It could take maybe like a half hour. Yeah, something like that.
Sounds pretty good. Thank you very much, sir.
Thank you very much.
Appreciate your
Okay.
time.